Alright, ladies and gentlemen, we're going to look at ellipses. So below I have a nice pretty ellipse of the Earth orbiting around the Sun. So ellipses are oval shaped. There's something important we need to know about an ellipse. We have two axes. We have a major axis, goes from here to here, and then we have a minor axis. It goes from here to here. Probably moved over to the left a little bit though, right? Here to here. Alright, so we're going to use those to help graph our ellipse. If you can graph circles, you can graph ellipses. They're very easy to do. I think you'll find this to be a very easy lesson. So the equation looks difficult, but you'll notice that it looks similar to the circle equation. If we just cover up this a squared and b squared, if we ignore those, it looks like a circle equation. So just like the circle equation, the center of our ellipse is going to be at HK. This A and B, these guys are going to be work with our axes. Alright, so let me write down an equation so we'll be able to kind of get an idea of what an ellipse is going to look like. Y is say plus 3 squared over 9 equals 1. So we have an equation here, right? So parts of an ellipse, we have a center. So the center of this one is going to be at positive 1, negative 3, right? We change the sign, so positive 1, negative 3. Positive 1, down 1, 2, 3 is going to be the center of my ellipse. Then this represents my axis that goes along with the x. So it's going to be my horizontal axis going left to right here. And the axis is going to be equal to a. So I need to take the square root of this number to get a. So in this case, a is going to be equal to 5. So I'm going to go over 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Alright, so that is my horizontal axis. Okay, and then we can go up and down with the b value, or here. So b is going to equal 3. So we need to go up 3, and we need to go down 3. Now if we connect this, it's going to look something like, oh, almost. It's going to look something like that, an oval shape. All right. So let's look at one last one. We'll call it a day. So here we have an equation. Let me get rid of some of this stuff. Oh, better hurry. We have an equation. The center is going to be at 2, 4. All right, 2, 4 over 2, 2, negative 4. I'm sorry. 2, negative 4 over 2 down 1, 2, 3, 4. My horizontal is going to be over 3 and over 1, 2, 3. And my vertical, I'm going up 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6 to here, and here is my oval. So we have a major axis going up and down now. That's my major axis. And my minor axis is going this way. That's going to be my minor axis. So notice if the value below the y is bigger than the value below the x, my ellipse is going to be going up and down. And if the x is bigger than the y, it's going to be going left to right. Your calculators will actually also graph these. I've kind of done it for you here. You can put the equation in the same way that you put the equation in for a circle, the same spot. And there are some kind of neat things you can do with this. There's one thing that ellipses have. If we go to menu and analyze our graph, and we choose the last one there, conics, because these are conic sections. Ellipses have two foci. Alright, so we click on that, and we'll click this, and we get some values that are hard to see. So I'm going to move them over here, and move this one over here. Notice these two dots that showed up, one below, one above. They're what's called foci. So there's one foci that's going to be up here somewhere, and one foci that's going to be down there somewhere. And our graph shows them, and it gives us the exact points of them. Those foci are important in ellipses. We'll do a little activity in class, and I'll show you where they come from. They actually help create the ellipse. All right, that is all for this lesson. We'll see you in class.